One more example with using the table method. If you don't, if you don't like this method, you don't have to use it, but we're still gonna follow our steps and use the table method on this one. So our first step is gonna be to factor these numbers. 14 factors into 2 and a 7, 35 factors into a 5 and a 7, and 49 factors into 7 and a 7. So this one was a very quick group to factor. Now I told you guys before that across the top would be our numbers that we're factoring. So I have 14, I have 35, and I have 49. Across the vertical column here, we're gonna put the numbers that we got out when we factored. So 2s, 5s, and 7s are the three numbers, 2, 5, and 7. Okay, and you can even make this more of like a box grid if you'd like. So then what we're gonna do, in our grid, we just kind of take tally. On 14, we had 1, 2, and 1, 7. In the 35 column, we had 1, 5, and 1, 7. And then in the 49 column, we had 2 7s. Okay, so 7 to the second. And I'm just gonna zoom in on this column, this table here. So I said that you have to take the greatest number for each of your factors. So 2, obviously we just had 1, 2, we had 1, 5. But when you look at your 7s, we had 7 to the first, 7 to the first, 7 to the second. You have to take 7 to the second because there was the most of those. So now we're gonna take and multiply 2 times 5 times 7 to the second. And when you do that multiplication on your calculator, 2 times 5 times 7 squared gives us 490. And that would be our least common multiple of those three numbers. For the sake of doing this one more time, I want to prove to you that sometimes this is more useful. So let's do number 20 from your packet. We're going to do the list method with this one as well. Okay, this one has 4 numbers, and so this one can be kind of tricky. So what I'm going to do first is I'm going to factor all of the numbers first, just like we were doing before, and you guys might have to write kind of small here. We have 24 could factor to a 4 and a 6, which would go to a 2 and a 2, a 2 and a 3. 30, we could get a 3 and a 10, which could go to a 2 and a 5. 48, we could do 4 and 12, 2 and 6. Ooh, this is gonna get crunched here. 2 and 3, and then 4 goes to a 2 and a 2.
Can we do it on another page?
You could do it on a separate piece of paper, yep. And then 60 is gonna go to a 6 and a 10, 2 and a 3, 2 and a 5. Okay. Okay, so then using my table method like I did on the other side, we're gonna make a table. Across the top, we're gonna have our 4 numbers. So 24, 30, 48, and 60. In our vertical column, we just have our factors. So we had 2s, 3s, and 5s. So 2s, 3s, and 5s. And then we're going to take a tally of how many of each one did we have. So if you look at 24, how many 2s did we have? 3. So this would be 2 to the third. How many 3s did we have? 1. And we did not have any 5s. When you look at 30, I had 1 2, 1 3, and 1 5. When you look at 48, I had 1 2 3 4 2s, 1 3, and 0 5s. And then when I look at 60, I had 2 2s, 1 3, and 1 5. Okay, now your job is to find the ones with the greatest exponent in each factor. So 48 had the most 2s, so I'm going to use this one. They all had the same number of 3s, so it does not matter which one I use. And then these two had the same number of 5s. So again, it does not matter which one I use. I just randomly picked one. And then to do your least common multiple, you are going to multiply them. So 2 to the 4th times 3 to the 1 times 5 to the 1st. And then you can put this in your calculator. We have 2 to the 4th times 3 times 5, 240. And that's how you find the least common multiple. So when you get a whole bunch of numbers, I definitely think this way helps you organize them.
How did you